I will begin with a foreword and then we will begin the session. The behavioral models are widely used to picture capability of a customer to respond to targeting campaigns. Not less importantly, they as well provide insights about customer behavior after the event of contact took place. The speaker is going to discuss novel upsell models and will describe various segments of customers in terms of their common patterns of post-targeting response. Please welcome our speaker today, Yaroslav Svyryda. He is our freshman at SoftServe, who in fact is quite seasoned specialist with rich expertise in applied econometric modeling and analysis. Yaroslav, the stage is yours.
Yeah, thank you very much, Daniel. So, welcome everyone. And today I will briefly describe you and tell you about uplift models. First of all, we will talk about using AI in marketing. This is something that probably is used now a lot, and then I will also share you and explain why those uplift model are actually really good solution for your marketing campaign. So first of all, let's go to agenda. As I already mentioned, in like first on the first like part of our presentation, I will tell you how AI is used in marketing. I will briefly describe you a few examples of using of machine learning in recommendation, in price and promotion optimization, and other things. Then we will slowly go to uplift model and why they, I'm sorry, to marketing campaign targeting. How is it done now? How machine learning models are used today to target your customers, to understand which will respond in the best way. And then we will go to uplift modeling and understand why uplift modeling are those models that are trying to understand how your contact and your marketing campaign really influence your customers. During this session also, I will show you really simple example in Python, when we will compare some uplift models and some of its usage, and compare some models on known data set. And then, of course, you will be able to ask me questions during our Q&A session. And also you will be able to share them using a QR code, so that will be presented in the end. So let's start. First of all, as we probably know that AI is widely used in marketing. Actually, machine learning is really widely used in pretty every domain of the business, but I believe that marketing is the one domain that using machine learning really a lot. So let's not focus on only some types of this usage. First of all, let's consider churn prediction. This is something that probably all big companies are doing, those churn models that are trying to predict when customer will or even will the customer leave the company. Sometimes for those customers are made some benefits or some special plans, or some contact is made for them to prevent them from leaving our company. The next thing is customer lifetime value estimation. This is something that answers your question: how should we treat our customers? Which group of clients could bring the highest profits? So we are even able to estimate what is our expected profit or revenue from some specific customers during his adventure with the company. And of course, knowing that information, we are able to ask more advanced question. How could we increase our customer profitability? Maybe we can go to them with some new products. Maybe we can inform them about some new subscriptions, some marketing campaigns, or something else. Other thing is customer targeting. And this is probably that you maybe now understand that we will talk a lot today. But let me briefly describe. First of all, we are able to answer for such questions like who should see our ad. Like, as you maybe know, there is plenty of advertisements in internet, in online and offline. For example, each time you see like pretty each time you see an advertisement on internet, probably there are some companies that are trying to show their advertising to you, and they're trying to propose the higher price. And this is why such models are used, because you want to know that like you really want to show this advertisement to these specific customers. And some models are able to predict what is the probability of some of such type of customer to converge if he will see our model, because there is no sense to waste money for customers that for 100% will not respond to our ads. And the other question is, how should we communicate with our customers? Should we do it online or offline? Do we have to write them email, or maybe to call them, or something else? The next thing is recommendation engines. Maybe you also heard about it, but I'm pretty sure that you have some experience with them. When you are scrolling some Amazon web page or Allegro in Poland or something like that, you possibly found that there is some recommendation that some customers also bought this product and they like this one. So maybe you want to buy this. Also, recommendation engines are used in some Spotify platforms or YouTube. There is plenty of such machines, like such models, like everywhere. And the last thing that is maybe the hardest one, this is price and promotion optimization. So which price will maximize my profits? Which price, how our customer will react to different prices. And actually this field and fields of customer targeting is a little bit different from all of them, because those fields are in these fields, we are not only trying to predict will customer buy something or no, we want really to understand what we can do to increase our customers' probability to buy something, or what we can do to increase our profit. And this is extremely hard field of machine learning and data science. And today we will focus on only part of it, only a smaller part of it, that is called customers targeting. This is our today's topic. So first of all, let me maybe go deeper in the idea of how ML actually is used, what is an ML application today for marketing campaign. First of all, we have to understand what is our goal. And like for most of the time, our goal is to maximize the profit or revenue, or maybe conversion when you are not looking for money. The next thing is, what methods do we have to do it? We are able to directly communicate to our customers. We are able to call them, to send them an emails, or maybe to show them an advertisement in internet or even in offline. The decision-making task, of course, is to understand whom we should to show our advertisement, or who we have to contact to increase our profit, and in the same time to make the cost be as low as it is possible. And how is it done now today? First of all, this is the classical ML approach that maybe when you will open any book on machine learning, there will be like a book example of machine learning. So some classification, we want to classify customers that will buy something from us, or they have the highest probability of buying, or that have the highest probability of churning. And like normally you'll use those models to understand to which customers you want to call, which customers you want to target, to talk with them, to make them to buy your product or subscribe or not to churn. Alternatively, of course, today when the cost of information is approximately zero, you are able to reach out to as many customers as possible, maybe to everyone, because when you are really a big company that is able to send an email even without any cost, probably it's not the worst idea. If your cost of contact is so low, you're actually able just to spam all your customers with your promotions or new products. And examples of such activities are upselling or retention, when we are trying to contact customers that probably will try to leave us or no. Or cross-sell and treatment effect estimation. This is something that we will talk today. So how could we change our price, for example, to make our customers to buy something? How can we contact our customers to really make them to buy our products? But let's now focus on machine learning approaches, or maybe not even machine learning approaches, but let's, for example, think about the easiest and the simplest possible model that is possible. So it's contacting everyone. Actually, if we have really low cost of contacting, we are able to do it. Why not? If we assume that if we will contact for our customer, if we will contact our customer, it will not harm us. They will not like decide not to buy something from us. If we will contact them, then we are of course able to do it. What we will observe in such situation, as you can see here, is a graph of random contacts. So, for example, if you will contact like 10% of your customer base, like statistic tells you that you will have like a 10% of your maximum possible response. So, for example, you know that from the historical campaign that there is a maximum response rate of your customers on like 30%. So, if you will call like 10% of your customers, 3% of all customers that could respond, you will find them. And this is a naive approach. Just call everyone and just assume that everyone, that the word that could happen, that they will just not buy anything. They will not change your, and the best, like what could happen, of course, is that they will buy something from us or that they will subscribe. Another thing is contacting only customers selected by some models. And I use there the word propensity model. So what does propensity in such situation mean? We are not trying to predict what will be like the response from our customers to this campaign. We are trying to predict what is the probability of this customer of buying something from us, of subscribing. And of course, machine learning models are good in it. We are like humanity and like a data scientist, we are good in classifications problem when we try to classify something, when we try to understand who will buy something and who will not. And maybe here this is a good idea to remember the Pareto rule, when 20% of all your forces are responsible for 80% of your results. So in such situation, you are able to build a really good model, and then you will sort all your customers like from the highest probability to lowest probability of buying, and you will call them one by one from those that has a high probability of buying to those who have the lower probability of buying. And in such situation, you will see something like there. We have model results um, here, and the white line is actually our model line. It represents our model response rate. And as we can see, we even contacting 30% of, for example, of course, it's only like an example. Our model could be best, could be worse, but this is like the true power of this machine learning. So if we will contact like 20% of all our customers, probably we will have like already 80% of those who will respond. And now we are able to cut all our costs. So we are able to use our resources more efficiently. Instead of like wasting time and money to contact everyone, we are able to contact only 20% or 30% and have 80% of all those who will respond. And just use another like your costs and your money or people to make something, maybe something else that will also generate for you a profit. But just wait a moment. As we were talking about, what could possibly go wrong? So first of all, when we are talking about propensity models, so where we are talking about the models that are trying to estimate a customer's probability to buy something or to subscribe, we have to first of all ask ourselves some questions. Mm, Just just imagine that we've done all it. We created this propensity model, that we made our campaign, and of course, if this model was good, probably you have some profits. Like you are contacting, you are really effective. You are contacting your customer in an effective way. So only by like contacting 10% of customers, you have already like 30% of maximum response or something like that. But here is a question. Um, did my ad actually influence the customers to purchase me? So if I will not contact those customers, would they buy something or no? or they will not buy. In such situation, of course, we have to contact them. But if I will contact them and they will buy, why should I contact them? Or vice versa, if I will contact them, they will not buy, but they will not buy even if I will not contact them. So I just wasted my money for this contact. And this is the idea of uplift modeling. This is something that we will focus on. We will try to estimate a real treatment effect, a real effect of our marketing campaign. We will try to understand how our marketing campaign is better than just not doing anything. So first of all, let's think about the main segments of our customers, how our customers could look like. First of all, let's think about those who we will target then. Those are that called pursuitables. There are customers that will buy something from us only if we will contact them. So actually, those are customers for whom we are really making our marketing campaign. Because if we will not contact them, they will do nothing. That will not buy anything, that will not subscribe, and there will be our like lost possibilities. Um, the other clusters too that from our perspective are like neutral. There are sure things and lost causes. Sure thing, those are customers that will buy something from us for 100%. We don't even have to contact them. They will buy it like nevertheless because that was their decision. And another possible, or of course, segment is lost causes. If those customers, if we will contact them, they will not buy. If we will not contact them, that they will also not buy anything. So as you can see here, we already found who we want to contact. We want to contact those pursuitables, and we really don't care. Do we need to contact those sure things or lost causes? Because it will not change anything. We will only like waste our money. But there is something more dangerous even. There's something that is called sleeping dogs. Those customers are customers that like in situation, if you will not contact them, they will subscribe or they will buy something. But if you will contact them, they will change their decision. They will change their mind and they will unsubscribe or will not buy your products. Of course, this segment is somehow unintuitive. Why? Because it's hard to really imagine someone that will try to buy something, but then you as a company call them and they are not doing it. But let's imagine a situation that, for example, you have some service. Like in my example, I have like two services for music, and one services I use a lot and another I'm not used for 100%. And let's imagine that I just forgot about it, but I'm subscribed and I'm paying some fixed fee each month. And let's imagine that in one moment that will try to contact me, they will write me about some benefits of about some promotion. And in this moment, I will just remember, oh my God, I'm paying for something that I'm not using. And I will unsubscribe. And this is something from a company's perspective, this is something bad because they are losing their money and they are losing their customers. So of course, sleeping dogs could be like not so bad example, of course. There could be an example like those are just people that just don't like to be contacted. They just don't want it. And it's also pretty okay. We don't have to contact them either. So just to summarize, first of all, who are our main targets? Those are those pursuitables. So there's those customers that will buy only if we will contact them. Because if we will contact like sure things or lost causes, that will not change anything. They will buy or not buy. We will just waste money for our marketing campaign. We will hope that the like this cost is really low and maybe we are able to contact some of them, but we also want to minimize the number of such people. And of course, we will for 100% don't want to contact those sleeping dogs, those customers that will change their mind, and actually contacting them will harm our business. And that's pretty all. This is the all intuition of uplift modeling, the idea of what we are trying to predict. We are trying to predict how our customers will react on our marketing campaign. Not will they buy something or no, but their reaction on our contact. Um, but the problem is that actually it's extremely easy, probably it's extremely, the intuition behind it is extremely easy, but it's extremely hard to implement. But before implementation, let's go to some metrics that that we will use today and we will talk about today. So first metric is an uplift. Let's think about it. If we will contact like 10% of our customers that have the highest possible from our model, they have the highest possible response rate, we will have like a response rate 5, 6, 10 times higher than in our population. So if response rate in all our population is like 3%, and we will contact only those 10% that we believe that they are the most pursuable customers, they will answer us, we will have like 50 or 60% of response rate. This is extremely high response rate that was caused only by our model. And this is something that we want to do. And this is something that you can see here on this uplift chart. So on the left side, those green bars, those are those customers. If we will contact them, if we will contact those groups of customers, we will have extremely high response. And this is someone that we want to call them. We also are able to transform this uplift, like this probability of answering us, to like more like to money. So in case we have, for example, some fixed cost, like any fixed cost and also fixed revenue for each customers, we are able also to understand when we have to stop contacting. Because as you remember, first of all, if we will sort all our customers in such way that firstly we will call those that have the highest probability to answer for our campaign, if and only if we will contact them. And in the end of this list will be those customers that will change their mind and they will not buy anything from us if we will contact them. This is how this uplift curve will look like. So first of all, we are increasing our revenue, we are increasing our profit. Then we are in this like area of value adding customers. Then we are going to those neutral. Here, the response rate is pretty the same as in control group. So then, I'm sorry, then here the response rate is like normal, something that we are expecting. For example, we know that normal response rate is 3%. So here on the left side, we have like 30%. Here we will have like 3% of response rate. And when we are going on like the right side, here we have sleeping dogs, those who we do not want to contact, because contacting them will only decrease our profit. This response rate will be lower than in normal population. This is an uplift curve. The other thing is a Queenie curve, and we can somehow think of it about like as cumulative uplift, or like about a cumulative revenue. Intuitively, you can think about it like that. Here, as you can see, let's imagine that there is our model. We have three segments. First of all, we have a value adding segment. So so customers, if we will contact them, they will respond, we will have some additional profit, and we will increase this profit like for first some percentiles of customers, we will increase it very fast and dramatically. Then in some moments, we will start to call only for those persons that are like sure things and lost causes, for those that will not change their mind. And here, this like uplift, like this response rate will stop. It will increase monotonically or even start to decrease. And then we will call to those lost to those sleeping dogs. So as you can see, our profit will start to decrease, because if we will not contact them, our profit will be on this level. If we will start to contact them, we will decrease our profit. So this is actually two main measures of our uplift models. And the idea is from this to understand which percentage of our customers base should we contact to maximize our profit, to maximize our response, and of course, to lower our costs. So here, as you can see, let's think about those bars also as a marginal profit. So you will maximize your profit, your revenue, in case your marginal revenue like is the same as your marginal cost. As you remember, our cost is the same. There is no like differences if we contact some persons with lower probability to buy of than higher probability. For example, it is the same for all the time. So when like our marginal revenue is the same as our marginal cost, we can stop and for example, we are able only to call for 30% of our customers and already have like 80 or 90% of response that we are able like to think about. So if we are thinking about 3%, like 10% of response, for example, we will come only to like 20% of our customers, and we will have like this 10% of response for all our population. So we will choose only those who will really respond to our marketing campaign. And this is the most important thing about uplift modeling. The next thing is, how are we able to validate those models? There is a tricky question, first of all, because when we are trying to train them, of course, we are not able to tell uh, how this person will behave if we will contact it or if we will not contact it, because we already done something on that, we contacted or not contacted them. But of course, when we are like using this model in production, it is possible to like online understand and validate how our model is behaving. We are able to look in our like response rates and compare it to like our estimates of response rate or the normal response rate if we will not do anything. We are looking to look for our cumulative profit, and if our cumulative profit is increasing like this curve, this probably means that we are doing everything right. So it's not so hard to estimate, to validate those models in real life, but becomes a little bit harder when we are trying to train them. And this is something that I will also explain you when we will go to some practical examples. But now let's go to other main questions. So as we understood, the main question of all marketing campaign and of all uplift modeling is, do we have to contact someone, or do we not have to contact anyone? Because let's imagine that now we think, do we have to contact this person or no? Because if we will contact them and they are pursuitables, it's great. If we will contact them and they are like lost causes or sure things, it's not so great, but there is not a disaster. But if we will contact those sleeping dogs, there will be a disaster. So this is why uplift models are really important in this situation. And now let me describe you how to create this model, how to train this model, and how to validate those model on your training and test data. So first of all, unfortunately, to make all the thing work, you have to invest some additional time and money for this. Because first of all, you have to make an experiment, a real experiment, when you will have a control group and when you will have a treatment group. So you will have some customers that you will not contact for some period of time, and you will have some customers that you will contact for some period of time. And then you will just observe how they're behaving. So you will just have some data set. In the end, you will have a data set that contain from your customers' features, from understanding like a flag if this person was contacted or not. So is it from a control group or a treated group? And you will see a conversion. So what this person like purchasing something from me or subscribing or not. And this is something, this is a data set that you are able now to use for your uplift modeling. So as you can see, actually you need two groups. You need a control group and you need a treated group. You have first of all to run an experiment. The interesting thing that even if during your experience you will find that response in your control group and your treatment group is the same, is pretty okay. So uplift models could really help you even in such situation. Okay, so how to train those models? First of all, there are two main approaches. First of those approaches is two-model approach. It's pretty intuitive, probably, because what you have to do, let's assume that you have some customer base. You have all your customers, and now you will run an experiment. You will choose a control group, and you will choose a group that will be treated. So then after this experiment, you will have this information. You will hear information about who converged, who purchased something from you from control group, and who purchased something from you from treated group. Then probably the most intuitive thing is to build just two models. So in control group, you will build a model that will estimate the probability for such person to buy something from you if it is not contacted. And in target group, you will create a model that will try to estimate the probability for some person to buy something if this person was contacted. And here actually is your uplift, because the differences between those probabilities, let's assume that for some imaginary person, the probability that it will buy something from you if you will contact this person is 70%. But the probability that it will buy something for you if it is not contacted is 40%. So as you can see, the uplift is like 30% from your model. And that means that you are increasing like this probability of buying if you are contacting this person. And probably that means that you have to contact this person, nor that not to contact. And this is actually a uplift score. This is something that you will actually use. Another thing is one model approach. And one model approach is more a little bit tricky because it requires using some specific models for it. So the start of an experiment look the same. First of all, you create a target, you create a treated group and you create a control group. Then you create a model that is trying to predict, to estimate this uplift directly. So the results of your model will be actually the uplift. Those models are actually used and based on decision trees, and they are mainly implemented in R. I wasn't able to find any such model in Python, but they are actually in R, so you are able to use them. And such models have just a good performance, and as we will talk in like later, they have somehow better better scores than two models approaches. So that's it. Actually, you are able also to build two models and then to look for differences between estimates from those models, or you are able to build one model that actually is created to estimate this uplift directly. And now let's talk about pros and cons of such models. So first of all, what is a plus and what is good about two models approach? First of all, they are very intuitive, because if you are thinking about like this approach is, it's okay to understand it. You are trying to estimate a probability of someone to buy something from you if you contact this person, and you are trying to estimate the same probability of something of this person to buy something from you if you will not contact this person. The higher is difference between those two probabilities, this is your uplift. But unfortunately, there is a problem because such models are less precise. Why? First of all, because they are good only in theory. Because they are good only if you are really able to estimate this probability of buying in the right way. But we all know that in real world data, we have noise, we have some bias, and we have some other problem because of which actually we have an error of our model. And if we are using two models in the same time, actually this error could like accumulate. So error from two models are summing up, and it could actually increase very much your uplift model error. So this is why in real world, such models are not so precise as normal as one model approaches. And one model approach is only to estimate uplift directly. There are actually two possibilities. First one is to estimate uplift directly, like tree models, some random trees from causal lifts, as I remember, package from R. Or you are able to somehow transform your target variable to use even like normal standard ML model. And this is something that we will also look on an example in Python. But actually, those two main possibilities. Of course, as we know, in real world, theory not always work as it should work. So this is why normally when you are trying to do it, probably you will may build like a few models. You will build two model approach. You will make one model approach, and only then you will compare them, and you will choose this one that works better for your data. So now let's move on to really small practical example of uplift modeling. Now I will stop sharing the presentation and will share to you Jupyter notebook. Um, I hope that you see my Jupyter. So first of all, um, let me quickly introduce data, because this is something that we will not focus on. Those are data from our package information, as you remember. Those data, we will not go deeper into features, but what we have to know is that there are also some marketing campaign. There also is a control and treated group, and there also is a target variable. So this purchase variable that we want to really predict. So first of all, what we will do, we will read our data sets. We will understand which variables are features, which variables are treatment, and which variables are targets. And then we will use it to train our models. So we will not go deeper actually in what those data means, because of course some pre-processing and some hyperparameter tuning will make our model work better. But for now, let's just compare those raw estimates. So first of all, let's also split our data on train and test set. We will only train our models on this train set, and we will use this our like test set, like this unbiased estimate of our model performance. And one thing that it's really important to say now is that unfortunately, uplift models on the smallest data sets are extremely unstable. So that means that sometimes everything could change even because of the seed. So this is something that we have to keep in mind when building such model, that we really have to cross-validate those models very well. This is something that we will not do today because of lack of the time, but this is something that we have to keep in mind. So first of all, let's look on how our data looks like. So first of all, what we can found that actually those data all are numeric, so we are able to use them directly without any pre-processing. But here is interesting thing, that actually this variable probably looks more like binning variable, not like a normal numeric variable. But as I already told, we will not change it today, because we will use from like tree-based model, so it should not be any problem. Let's go deeper. Let's see how many observations do we have in treated group, and in control group. And as we can see, we have a really good like half by half split. So that means that we have really similar number of observation in control group and in treated group. And of course, we have like 50% of customers that were treated, around 50%. The next thing is the percentage of conversions. So what is the percent of customers purchase something from us? And here we see that there is a 20%. Mm, And next thing that is maybe really interesting, that if we will compare this conversion rate in treated group and control group, we can see that they are pretty similar. So we have like 20% conversion rate in each groups. So for the first point of view, like for a first look, um, it sounds like our treatment does not work, because we are contacting some people, and we do not have like the higher conversion when we contact someone than if we not contact someone. Let's dive deeper and look how all those models will work on those data, and what is their performance on those data. So we will understand that even in such situation, uplift models are able to point to and increase this conversion. So first of all, let's look in propensity model. As we remember, propensity model is just a model that tries to estimate the probability of buying, not looking for treatment effect. Was this person treated or no? We are not looking for it. Well, not. We are only trying to understand if someone will buy something from us or no. So we will use for it random forest. We will use only like standard Python scikit-learn hyperparameters for it. And as we can see here, this is our cumulative gain chart. How we can think about our cumulative gain? What is a gain? Gain actually is a difference like between our estimated response and our response that we really have in such group. So if this response is higher than this random selection, that means that our model looks fine. And actually what we want to see in the ideal world is actually that this curve will look more like on the presentation. So it will not jump like here, it will not oscillate between random selection. So this is why propensity model is not the best idea for estimating this treatment effect, because as we can see in Uplift, if we will try to contact like those persons by percentiles, we will just score them by this by the probability of them of buying, and we will contact them. We can see that like only in first percentile we have some slightly increase in our response rate, but then sometimes it decreases, sometimes it increases, and it more look like a random model. So this is why propensity model in such situation is not the best idea. The next thing is two models approach. When we are trying to make some model for control group and some model for treatment group. In such situation, as we can see, we also using random forest. We are making predictions for new data from random forest that was trained on treated group and on control group. And now we see really good cumulative gain chart. As we can see, this model is 100% better than random model. We are able to observe really good uplift. We are able to see that actually contacting those person using this model will increase our response rate. And also we are able to see it on our uplift curve. So if contacting like 30% of our customers will actually make you to contact like pretty all customers that could respond to your campaign. And this is like a true power of those uplift models. The next thing is transformed outcome. What does it mean? So here we will try to predict not a probability like of buying or a probability of treatment. We will try to predict such variables. So we'll create a synthetic variable that will be one if in the same time the person was in treatment group and it's purchased something, and we will try to predict also one if the person is in control group and this person was not also purchasing something. And you can also try to find an idea like an intuition behind it, but such models though are those that are actually widely used in uplift modeling, and this is called like a transformed outcome models. um, as we can see, they work somehow better than propensity model, but also somehow worse than two models approach. As we can see here, also like calling first like 30% of people will work, we will have the higher uplift, but then you can see those spikes here, and that means that this function is not monotonical. This is not something that you want to see when you are training those uplift models. um, Next, maybe interesting thing is one model approach, actually from Python package that is called PyLift. It also creates a transformed outcome. So it's not creating any like tree-based method that are trying to estimate this uplift directly, because as I told, I were not able to find any packages in Python that are able to do it. But as we can see here, this cumulative gain is also good. So that means that contacting people by this model, but like the sorted list of customers produced by this model will increase our uplift. So this means that we will have the higher response rate in like the first percentiles of our customer that we are contacting. As we can see here, it's pretty okay also, because when we are contacting like those first percentiles of people, we have the positive uplift, but then it starts to oscillate, unfortunately, near like a random model when we are just contacting everyone. So this is also not something that we want to see. Uh, Another thing that we also are able to do is to create a neural network. Of course, if we have the high amount of data, because as we know, neural network are extremely like complex models in the sense that they need the high amount of data to be trained. And this is something that I came up when when I was thinking about deep key learning, that there is an architecture that is called dual key learning. You don't need to think like very much about it, but the idea is that we have a neural network that like have some inputs, have some dense layers inside it, and then you're just going to like two heads. One head is trying to estimate like a normal probability of someone to buy your product. And another head is trying to estimate this effect, is trying to estimate an advantage of buying of increasing this probability if you are buying some, if you are contacting this person or not. So here you can think about it as like a average probability for this person to buy this product, to buy or not. Here you can think about like those heads and like advantages. One of them will be like higher, one of them will be lower, and one of them will tell that, okay, if you will treat this person, if you will contact it, this is how your probability of buying will increase or decrease. And this is how your probability of buying will increase or decrease if you are not contacting this person. Then we are able just to add those variables like here. So you are adding your probability of buying and advantage of buying if you are treated. And of course, you are also adding like your probability of buying and advantage of buying if you are not treated. You can think about it like more that neural network try to estimate what is an average probability of buying for this person, and how in here it tries to estimate how this probability will change if you will contact this person or if you will not contact this person. And like by just dividing those things, like in the end, you will just trying to estimate what is the probability of buying if this person was treated, was contacted, or what is the probability of buying if this person was not contacted. And of course, like in this same moment here, we have like this idea of two models. We can subtract something from another and have like this uplift value. Uh, Here it is done in PyTorch. It's probably is not so important how it is done, but we are able to see that unfortunately, maybe we have not so high amounts of data to make it efficiently. So this is how like our cumulative gain chart looks somehow weird. So it has some spikes. Probably it's a little bit better than a random model, and maybe the neural network will learn better if we will do it by if we will do it on more data sets. And the last thing that we can also look for is those cumulative gain charts for different model. You can think about it intuitively in one way. So the higher the higher is the value of this curve, the better the model is. So we are able to see that like in our example, two models approach have the best possible cumulative gain. So it increases our, it is able to point us those customers that will buy something from us only if we will contact them. And that means that contacting customers by list sorted by this model will actually lead to increasing in our profits and in our response rate among those customers. Uh, Actually, I believe that this is all. This is a really small example, just illustrative example to compare some models and see like just an ideas how we are able to think about this problem, how we are able to solve it. And now let's me move on to a presentation. Uh, yeah, I saw that someone told about Uber causal ML. This is also a good library. So uh, let's now go actually to the end, to final of our presentation. So let's think about when we want to use our uplift models and when maybe we have only to use a propensity model, when propensity model will be enough. Because as I already told you, using uplift models is associated with the cost of this treatment, of this experiment, of creating this treatment group. And moreover, sometimes those models are unstable. So you have to be pretty sure that you are just able to use such models. So this is like a checklist. First of all, uh, you have to be sure that that the valid control group exists, and this is a really valid control group. That means that it's not biased. Those people were chosen to the control group only like a sample of a really random sample. That was no code that those people was actually in random group. The next thing is the volume. As we saw, actually, we really need a large amount of data to be able to train such models. Um, the next thing, let me maybe repeat one more time. If we have or we are able to have a valid control group, this is something that allows us to use uplift modeling. If this volume, if this control group is high enough also, this is another like point that allows us to use uplift modeling. Negative effect, that means that we really believe that there are the negative effects of our campaign. So if we will contact some people, they probably will change their minds and they will not buy something from us. So we have to be maybe not sure, but we have to have an assumption that something like that could happen. In this moment, we really need a uplift model, not a propensity model. Then is a complex customer influencer. So let's think about it in another way. We are able to contact our customers in a different way. We are able to call them, we are able to text them, to send them an email or other possible ways of contact. If we want to find the best one, we also need to use an uplift modeling to understand which is the best possible contact like channel that is possible. And then also is the last one is an anti-correlated effect that we believe that our like customers will that our customers actually, if we will contact them in a control group, they will have the same response. Probably this is something that could happen, that we saw actually, that even our customers have the same response in our control group. When we are using, when we are trying to make an uplift, we are able to make some gain, we are able to add some value. So this is something that we also have to look for. If in our control group the response effect is the same, does not mean that our treatment is not efficient enough. That just means that we also have a negative effect of our customers, that they, for some reason, some customers are pursuitables, so we are able to make them to buy something from us, and some customers are those sleeping dogs that will not buy anything from us if they are treated. So the last word that I want to tell, that you really want to use those uplift models in such situation when you want to understand this treatment effect, when you want to understand this effect of your contact to the person, not only to understand if this person will buy something or will not buy something. You just want to understand, should you waste your money for contacting someone or you should not? And this is where, when you're able and when you're actually asked to use those uplift models. And I believe that that's all. Thank you very much for for your time. Now it's time for Q&A. If you want to ask some question, you are able to use this QR code and ask your questions here. Thank you very much for your attention.